have a feeling this one's going to be another one where I'm kind of just staying out of the way. Uma and Vanishri are going at it.
When you get $1 worth of GPU compute, you're actually doing a lot more compute than like on a CPU.
That is how long ZKVMs will be relevant, so ZKVMs will always be relevant.
I hope that once Vanishri comes out of stealth with what she's been building, that you guys can collaborate as well.
GM, what's up guys? Welcome to another episode of The Rollup. Today we have a debate. This was a fun episode. It was a very friendly debate. We had a fun episode with Uma from Succinct and Vanishri from Firma. Firma has recently come out of stealth and they are working on custom ZK circuits. Uma takes the side of generalizable ZKVMs. This is a question of convenience versus customizability. There's lots of parallels that we draw during this debate. Ultimately, this one is a really, really good deep dive into ZK and a couple of nuances versus trade-offs of building a generalized environment or a very custom environment purpose-built for a specific use case. Hope you guys enjoyed today's episode. Before we get into it, a word from our sponsors. Welcome aboard on our journey into the singularity. This is the endgame roadmap for Frax and Fraxtal, the new L2 out of the Frax ecosystem that is totally based on fractal scaling. Fraxtal is a modular L2 blockchain built by Frax with modular and fractal scaling in mind. Fractal scaling is based on the Mandelbrot set of fractal images, and it explains how L2s become L3s and the entire app chain lifecycle goes through its evolution. The Frax ecosystem is made of some of the top builders in the space and has stemmed from its OG days of the Frax stablecoin. It is now in the LST space, the LRT space, and this Fraxtal L2 joins the existing suite of Frax products, including Frax Swap and Frax Lend. You can see Frax Ferry, the bridge to go from any chain, Arbitrum, Optimism, or mainnet into the Fraxtal mainnet, bridge your tokens, and bring your Frax assets into the Fraxtal ecosystem. Join today to get the best out of Fraxtal. You are still early. Join today, take part in our expedition into the singularity. Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today.
Welcome back to the Rollup, guys. Today's episode, we're going to be discussing the trade-offs of ZKVMs versus ZK circuits, kind of this idea of generalizable ZKVMs versus more specialized ZK circuits, kind of inspired by a tweet from Vanishri here a couple weeks ago, and almost like a secondary follow-up to our recent episode with Uma and Brendan about Succinct's impact on Polygon's ag layer. So yeah, tons to talk about. Excited. Rob, good to see you. I feel like I've been kind of AFK from these episodes for a couple of days, so good to be back. And yeah.
I'm going to get you back on real quick here. I have a feeling this one's going to be another one where I'm kind of just staying out of the way. And Uma and Vanishri are going at it. And yeah, we'll get it started here. But I think the idea here is like Andy said, ZKVMs and ZK circuits. What are the trade-offs? Why should we use one or the other? And talking about the designs of both. So yeah, I think first we'll get it started with some intros. Vanishri, you're new to the channel. Welcome. And why don't you start?
Thank you so much, Robbie and Andy. It's great to be here. Quick intro about myself is I'm the founder of Firma. Firma is a universal proof generation layer that is designed to generate proofs for any proof system in a cheap, performant, and reliable manner. And a little bit about my personal background is that I'm a cryptographer. I got introduced to zero-knowledge proofs long ago. Robbie and Andy, I told you the story a while ago. little quick stories that I learned about zero knowledge proofs when I was an undergrad kid in India in a remote town, and just was blown away. Who wouldn't get blown away, right? The ability to convince somebody of the verity of a statement without even telling them any information whatsoever about the reasons why it should be true. It just sounds so impossible at its face value, and how can there be so much of research and so much of advancements, and look at where we are. And very soon I realized this is what I wanted to work on, I think, for a long time, probably for the rest of my life. And since then, everything that I've done is in line with my goals of goals of working on zero knowledge proofs, doing my PhD at UCLA in cryptography, and working at various projects, including Mina, the Mina blockchain, on consensus protocol, the ZK circuits there, etc. And then Firma. Yeah, that's a little bit of background about myself. Thank you.
Awesome, Uma.
Hello, I'm Uma. I think I've been on the podcast before. I'm one of the co-founders of Succinct. We're building a ZKVM called SP1. So basically what SP1 lets people do is it lets any developer just write normal Rust and then use ZK. So you don't kind of have to write ZK circuits anymore. And then we're also building a decentralized prover network around SP1 to make it easy for anyone using SP1 to use one API call to get their proofs generated, and not have to set up their own infrastructure.
Sweet. Okay, guys, welcome on. Pleasure. Thank you for taking the time. I think to kick us off, gonna pull up on the screen here the tweet from Vanashri. I'm gonna read it out loud for those who aren't watching on YouTube or on our website. So Vanashri tweeted on July 28th. Here's a controversial take on the future of ZK. Ready? In short, for any given project, ZKVMs will fade and custom ZK will take over. Here's why. ZKVMs have been crucial for widespread adoption by significantly reducing time to market. However, this comes at the cost of high resource demand for proof generation. While this cost is decreasing, custom ZK is likely to be more performant. Consider an application's evolution. It starts with ZKVM, finds product market fit, achieves success, and then aims to improve its performance. Transitioning from ZKVM to custom ZK becomes an obvious choice as time to market is no longer an issue. Now, to be clear, this doesn't diminish the value addition of ZKVMs at all. I think they will be forever essential, but as a bootstrap mechanism for any new project. Feel free to challenge it. And Uma kind of came back with a challenge, which I'll pull up on the screen shortly. But first, I think to explain your point of view further for the listeners would be great to kind of hear more from your side there.
So before I talk about the exact tweet, I want to start by acknowledging the amount of impact that ZKVMs ZKVMs have had on our space. I think ZKVMs have catapulted the adoption of ZK. They have significantly reduced the barrier to entry, by reducing the time to market and engineering costs. There is zero taking away from that, right? I think, like I said in the tweet, I think they're forever. They're here forever to stay. The bounds of my argument are the following. When a project reaches a level of maturity, when these bootstrap constraints go away, the bootstrap constraints of time to market and the bootstrap constraints of engineering costs go away, and when performance takes center stage, then the question that needs to be asked is, will ZKVM still be the right choice for them, or will it make sense for those projects to consider custom ZK circuits? And my thesis, as I mentioned in this tweet, is that ZKVMs are a great gateway mechanism for those projects, and custom circuits can increase performance. I think they will have a custom ZK circuits will have a space. Yeah, that's the that's the high level structure of my high level gist of my thesis.
Cool. Now I'm going to pull up Uma's, and then we'll kind of take the tweets down and just have a more kind of fluid conversation. So Uma, you went in and responded, which unfortunately, I mean, unless you want to hear me do another monologue, I think that we'll just pass on that one. But maybe you could also kind of summarize your key points here, and then we can kind of kick this off.
Yeah, for sure. So I think for some background, it's maybe helpful to even talk about my personal experience with ZK circuits versus ZKVMs. So, for around 2 years ago, like I was writing a lot of custom circuits. I was using languages like CircCom, like Plonky 2, which is more of a framework than a language, and writing custom circuits for, in particular, a lot of light client use cases, like a ZK Tendermint light client. And we wrote a lot of circuits. It took a really long time. It took like many months to write them. It took them many engineers. It was very difficult to audit. And in the end, we were pretty happy with the performance of our circuits. I think it was like, the proof generation time took like 10 minutes or something like that. And so that was our journey with ZK circuits. Then we built SP1. And with SP1, I think like our intern or something wrote the Tendermint light client. It took an afternoon. It was like 50 lines of code. The proof time was actually really, really fast. It was several minutes instead of tens of minutes. And then the proof cost was also a lot cheaper. Instead of being several dollars per proof, it was like a few cents per proof. And so I think my personal experience with the ZKVM is that it's been better than custom circuits in literally every single dimension. Like the developer experience is like 100x faster. The proofs are cheaper. The proof generation time is faster. And overall, like the maintainability, the auditability, the customizability is like unparalleled. So I think a lot of my thinking around why ZKVMs will totally dominate ZK circuits, even in the long run, is born out of this personal experience. And yeah, maybe I can talk later about, why I think that trend will continue for a long time. But yeah, I think that's like kind of that's like one data point, I guess, that, I think is really illustrative of like a real world example with these two different technologies.
I mean, basically, like let's open up the floor. So, Vanashri, if you'd like to respond, and then maybe we can go back and forth a little bit on these two competing theses.
I think the amount of like I said, the amount of advancement we have had in ZK space, it was even unthinkable. Even before SP1, RIS0, Joel, Nexus, ZKM, all these projects started. I am even guilty of the fact that I thought that it may not even be possible to build a ZKVM. So I actually am very stunned by the amount of advancements that these teams, including Uma's team, has done. Again, I think there are bounds of my statement, right? My statement doesn't even contest any of this. My statement actually goes to a specific situation where the engineering time is so small. The results you can get by the results on proving time you can get by applying ZKVMs now in comparison with the ZK circuits that have been built in the past might be a lot better. Here, all this completely acknowledged. Still, my point remains that as a project grows so big that it touches lives of billions of people. At that time, and also for a project where performance is critical, right? There can be projects where performance is critical. There are whenever you touch the entire, right? People are working with limited resources. Phones, even Nokia phones, old phones, not able to generate proofs on them, not having enough memory to even complete the proof, let alone however long it takes. These are all the constraints, right? When these become the constraints, and when a project grows to that level of maturity, the focus becomes competing. There won't be typically one project. There will be multiple projects, and they will compete. People will say 1 minute against 95 seconds, 1 minute against 55 seconds, and it's even milliseconds, even 1 byte of data difference can become the coarseness in which people projects can compete. So when that becomes center stage for projects, if it is the case that custom circuits can perform better than ZKVMs, I don't see projects holding back from putting together a cryptography team of, let's say, 10 amazing cryptography engineers working on ZK circuits for 1 year. That won't be a problem because cost isn't a problem at that stage. Time to market isn't a problem at that stage because these projects have already got around this problem through the use of ZKVMs. And there are, Uma rightly mentioned some important advantages of ZKVM, such as auditability, such as reusability of the code. Here are some important points related to that, right? One about auditability. When we are so I'm actually very skeptical about, I'm actually very cynical about the way audits currently are looked at in the ZK industry specifically, and for the following reason, right? When you audit, you need to get some level of assurance after the audit, right? And that level of assurance should align with your main goals. The main goals for a project, for example, somebody is building an application to transfer money from one party to another party, and they're using ZK. They want to make sure that that this money doesn't get lost, for example, or people are not going to mint extra tokens out of thin air without getting detected. These are the concerns of that project. The results of the audit should directly transform, somehow easily be inferable. The results of the audit should somehow connect with the goals of the project. And so contrast that with the current state of ZK. The current state of ZK is that we are going at a breakneck speed. We are going at a breakneck speed, at such a speed that we rightfully don't have the time to peer review all the security results of security analysis of every ZK advancement that happens, and how those security properties relate to the security properties needed by the application. And these are not just theoretical, right? Take, for example, what happened in Zcash. In Zcash, because of the bug that there existed, what it implied is that anybody could mint fake Zcash out of thin air and nobody could notice, right? These are real issues, right? And that is coming from an amazingly strong cryptography team. I think that's one of the most amazing cryptography engineering teams there exist. And still, there was a bug, and I think we have a long way to go in terms of audits being of a great of significant value to applications that are using ZK systems. So there is that point. I'll leave it there. Right. I think to summarize, my points are that there are various advantages of ZKVMs, but when it comes to the bounds of my argument, I think whenever custom circuits do make sense, the advantages of ZKVMs, the extra auditability, etc., will become minimal, and the ability of projects to expand on areas where the bootstrap constraints don't matter will make sense.
Interesting point on the auditability, Uma. I don't know if you want to comment on that specifically, because I think it's kind of an interesting thought with regards to how these audits are taking place, and also just like the discoverability of errors, which I think is interesting. And then Uma, if you don't have any comments on that, I'd like to ask you specifically about some components of your post as well. So let us know if you have any comments there.
Yeah, regarding the auditability, it sounded like your point. Well, I guess I'm not like 100% sure about the point, but I guess my view on this is like auditing any ZK system is super complex. And so if you hire, a team of cryptographers to make a bespoke ZK circuit, I think it becomes much harder to audit than, for example, an application built on top of a ZKVM. For example, with our ZKVM SP1, we've gotten many audits for it at this point. We've had a public code competition for it. Getting audits is extremely expensive, and then the auditing compounds over time, right? So like as we use it more, and then we design upgrades to the protocol, there's more and more pairs of eyes looking at the code base, and I think the security and auditability story just gets better over time. If you're making a custom ZK circuit for your use case, often you have actually a very similar amount of complexity to, for example, a ZKVM. Even for example, if you're trying to verify signatures or something like that, there's a lot of complex logic that goes into, making non-native field arithmetic work in a ZK circuit or all these things. And, obviously you're not going to spend as much money auditing one circuit versus one ZKVM that a lot more people use. Obviously, you're not going to have the same number of auditors or the same pairs of eyes on the code for a custom ZK circuit that is just much more limited in scope versus a ZKVM that a lot of people use across a lot of different applications. I think the beauty of a ZKVM is that it is a really general platform where it can benefit a bunch of different applications, right? So who can use SP1? I mean, basically anything in crypto, like rollups can use it, bridges can use it, and then basically any use case can use SP1. And so every day we're really motivated to wake up, go into the office, and make SP1 like 10% better. And we know that when we make it better, everyone benefits. And similar to that, like for our auditors, they know that when they're auditing SP1, that's an audit that benefits the entire ecosystem and all the people using SP1. And that means we can invest more in audits, we can invest more in security, more people can look at the code, more people have an interest in looking at the code as well. Like there's a lot of different teams that have, taken SP1, forked it like in a friendly way, added their own precompiles, tried to do their own optimizations. And I think through that, they're also looking at the code as well. And so overall, I think the security and auditability story for ZKVM, because it's such a general platform, is like a lot better than anything that's built custom. Almost, I would say definitionally. Perhaps like if you're building an extremely simple circuit that's like, tens of maybe not tens of constraints, but like tens of thousands of constraints, or like very, very few lines of code built on an existing circuit framework that's been used for a long time. So for example, CircCom, then maybe I would say you could like audit that securely. Like for example, I think the Tornado Cache circuits are extremely simple and something that are by this point, given how much money has been at stake at Tornado Cache, something that is very reliable, very secure, and we can all feel very good about. But I think for any other application that's like more complex, the ZKVM security story looks a lot better.
I have a few points of response to that. Thanks, Uma. So one is, I think I wanted to explain my point a little bit better about auditability. So the core aspect I meant is connected to the various levels of security a proof system can have, right? There is no secure, not secure kind of a situation. There are levels of security, right? Something can be only secure to an extent that there can be an application that is fine with that. but there can be application where you're worried about bigger kind of attacks that you need higher levels of security. Specifically, if you look at analysis, written analysis of security of proof systems, for example, GROT16, right? GROT16 is not, it doesn't have the highest level of security. It has knowledge, the so-called knowledge soundness, and the highest level of security is simulation extractability. They're just, I think they're named very badly. They don't tell us very much, but let me try to explain very in an intuitive manner what exactly these two levels of security mean. The lower level of security pretty much captures the notion of soundness, that you try to convince a person of the verity of a statement. You're not able to convince that person of a wrong statement. That is the basic level of security, right? The higher level of security is non-malleability. That, let's say Andy gives me a proof, then in a man-in-the-middle attack, when I'm playing, I'm talking to Uma, I shouldn't be able to transform the proof from Andy and fake it to come from my way. I don't have the witness. I'm not able to generate that proof. But Andy gave me the proof, so I have something to begin with. I can transform it, mold it, and give it to Uma. This is the non-malleability attack. This is like the man-in-the-middle attack, the HTTPS security. They are all related, right? So summarizing, there are multiple levels of security, and even GROT16, for example, doesn't have that higher degree of security. And there are applications where it makes sense, where it is important that you have that non-malleability, where you can actually create havoc if you're able to mold somebody else's proof as yours. And when that level of security is required, when my point is that our audits are our ZK space is going at such a pace that we rightfully, I think this is the right way to go still. I'll say that, I'll explain why, but I think the way, the pace at which we are going doesn't allow us the time required to analyze the level of security of these proof systems, and also on the application side, for the applications to think about what is the right level of security that they want, because it's just the state of, it's just the world we are living in, right? Applications, they're not ZK experts. That is why Uma and other Uma's teams and other teams are helping these teams to embrace ZK without knowing ZK, without having to think about this ZK in depth, without having to think about the security aspects in depth. So it's very natural. These all projects are not thinking about the security aspects. As a result, my question is, what does these what do these audits really tell us? What do these audits give assurance to these applications on? Imagine an application that needs higher level of security, but a ZK doesn't have that. A ZK proof system doesn't have that level of security. Then what does this audit give us? What does the result of these audits give us? That was my main point. Let me make a couple of other quick points. That while it remains true that the amount of brain power, the number of eyes that a ZKVM can get can compoundly affect a large number of people, a mirrored argument holds true for tools that can be built to make custom circuits easier to build. If more people and more people and more people are building, are advancing the area of tools to build custom circuits, it remains the same. So just the way we learned our lesson from not questioning our ability to build something as beautiful as ZKVMs, I think we shouldn't question the ability of our industry to build amazing tools that can help us easily build efficient custom ZK circuits. And one last point is that just the way, again, there is a mirrored argument, just the way ZKVMs can impact the entire world. In the entire world of projects that are trying to embrace ZK, tools that can be used to build custom ZK circuits can impact this project. So recall that we are talking about these projects that have reached higher level of maturity, right? They have impacted a significant number of people. Now, anything that helps them impacts, again, a large number of people. These custom tools that can help you build custom ZK circuits, that thereby helps these really advanced projects, which are impacting an entire world, can help this entire world. So I think there are mirrored arguments. In summary, I think ZKVMs are highly impactful. Custom ZK circuits can be highly impactful, but just in two different ways.
Welcome to the Ignition, Mantle's newest campaign to liberate the growth power of Bitcoin. FBTC Ignition has officially begun with a total token supply of over 2,000 FBTC with a TVL of over 150 million. Right now, you can go on the FBTC website to see all of the featured campaigns, staking opportunities, and liquidity pools where you can utilize FBTC on-chain today for some of the best yields available on L2s. The Ignition Sparkle campaign can be found at fbtc.com/ongoing-campaign.
Okay, Uma, let's put this into kind of terms for like an example that we can understand. I think your tweet was an example that like, I mean, hopefully we can understand. There's a lot of this that is kind of I think still probably a little bit difficult for the broader community. So I appreciate you guys kind of breaking this down for us today. But you put out your kind of rebuttal with regards to this Tendermint light client example, and kind of talked about the proof time, proof costs, lines of code, and engineering efforts for a custom ZK circuit built with Plonky 2 versus a Tendermint light client built with SP1, which is Succinct's ZKVM. So let's just kind of unpack the key factors that allowed SP1 to outperform this custom ZK circuit in this example from those that I mentioned, as well as just kind of like how the performance and development time compared and what your key takeaways were in addition to kind of the broader conversation here.
Yeah. So I think a really good question. So, just to touch on what you said, in my tweet response, I said we built the same fundamental application, ZK application in a Tendermint light client using custom circuits with this library in Plonky 2, and we built the same thing with SP1. And basically the SP1 thing was just better in every single dimension. Like, it was way easier to build. It took way less time. There's way fewer lines of code. I think it's much more secure. The proof costs were way cheaper. The proof latency was way better. And so overall, it just seems a lot better. And I think one very natural question to ask is, it feels like we're kind of getting free lunch. Like, we just improved upon our old stuff with the custom circuit world in every dimension. I think it'd be pretty believable if I said, oh, the Tendermint light client with SP1, the developer experience is a lot better. It's 50 lines of code, but it's a lot slower or something like that. So there's some trade-off. But the argument I like to make with ZKVMs is actually there's no trade-off. And I think it's really helpful to understand why that is the case. So with SP1, because again, and I'll go back to this platform analogy, SP1 is such a general platform and such a general tool that can be used across every single vertical in crypto, every single company in crypto, right? Rollups, bridges, any use case can use SP1. If you want to use ZK, you can use SP1. And because it's so broad and general, we can spend a lot of engineering effort really optimizing it. So to give a really concrete example, with SP1, we spent many engineering months, almost probably a full engineering year, making a GPU prover for SP1. So we took SP1, we wrote a lot of very complex, difficult GPU code, and then we run SP1 on GPUs. And with GPUs, the proof generation times are a lot faster because GPUs are, good at that. It's also a lot cheaper because on a cost basis, when you get $1 worth of GPU compute, you're actually doing a lot more compute than on a CPU. And so for us, the GPUs ended up being a lot more cost effective and also a lot faster than proving SP1 on CPUs. Now, there's no way we would have spent an engineering year optimizing our Plonky 2 light client and putting it on GPU. Like, that makes basically zero sense. There's no engineering ROI there because it's just for one application, it's just for one use case, it's just for our one team. So we would have never done that. That wouldn't have made sense. But for us, like, it was definitely worth putting in engineering resources to optimize SP1 because not only did our Tendermint like client with SP1 get better, all the other rollups who want to use SP1, those all got a lot better. And so that's like a really concrete example of why having such a general technology that can benefit a bunch of different applications is so powerful, because then you can go and optimize every single corner of it in a way that doesn't make sense if you have like a particular specific application. Kind of like an analogy I like to make is with machine learning. Like I live in San Francisco, so that's all the rage here. But also in the broader world, you had like machine learning's existed for a really long time, right? You've had all these like small models and, you know, you've had these LLMs actually for a long time. When did it go mainstream? It went mainstream when GPT-4 and ChatGPT came out. What is the beauty of ChatGPT? It's a general purpose technology where you can just put in English and then it spits back out English, and now anyone can use AI, right? Like, you can use AI by typing through your ChatGPT app. There's a lot of other AI-powered applications where the developers building those applications, they just call the OpenAI API. They put in just whatever, your emails, like documents, whatever else, and then, you know, you put in like, hey, ChatGPT, can you tell me about X, or can you find this information? And then you don't have to do any customization. You don't have to do any fine tuning. You don't have to do any of this like complex AI stuff. You just like use general purpose GPT-4 and it just works for a variety of use cases. And that's when AI really went mainstream, is when we had this general purpose technology. And I think it's very similar in ZK. Like, if I think that ZK is an extremely powerful technology and it will go mainstream when anyone can use it by just writing normal code. Like, it used to be before that you had to like do all this custom circuit stuff, you had to put in a bunch of engineering effort, and if you're just building one single application, the ROI is not there to actually optimize it and like, you know, audit it and even spend the developer time and energy. But then once you make it general purpose and you make it easy for everyone, I think that's when it actually gets adopted. So yeah, I see a lot of parallels and just like from, you know, ZK circuits to ZKVMs being really similar to like the shift in AI being super general purpose as well. And so that's why I think maybe that analogy is like also pretty helpful to kind of reason about why I think ZKVMs are just like going to the future.
Yeah, and Uma, maybe you can. I have two things here for you, and first is, okay. So with this generalizable idea, we have there's obviously, you get rid of all of these kind of trade-offs of the engineering effort, which I'd like to kind of touch on. But first and foremost, would you agree that by writing custom circuits and optimizing for specific tasks, that if you do all the engineering effort, if you fund it all, if you go through the entire, what you're basically kind of alluding to as being a lot of work and somewhat of a headache, do you agree that the outcome for certain specific tasks is more advantageous than using a ZKVM? Are there certain tasks that you think the outcome are more advantageous if you go through the entire process, setting aside the process and the headaches involved? Or are you saying that regardless of the outcome of a specific task, ZKVMs are better for, you know, the entire spectrum?
That's a good question. I think for a certain use case, for example, okay, let's take the Tendermint Lite client because that's our favorite example during this podcast. If you maybe spent a few engineering years, you spent like millions of dollars on engineering, like, you know, engineers, perhaps you could make a custom circuit for a Tendermint Lite client that is better than the Tendermint Lite client in SP1. I think that is possible. Now, one thing I will say actually is like, okay, people like to talk about circuits. So let's kind of talk about what is the difference between a circuit and a VM. So in a circuit world, for example, a circuit means that you're taking your computation you want to prove and you're writing it as like a fixed computational graph. So you're basically writing it as this like series of gates and wires that's like very fixed. Like, to make it super concrete, like you don't have like for loops and you don't have like dynamic if statements and you don't have like branching logic. It's all just done as a fixed graph. In a VM with normal code, we have like normal control flow logic. Like you can do dynamic for loops, if statements, stuff like that. So actually, for example, for Tendermint, there is this interesting phenomenon where in a light client, you often don't actually have to verify all the signatures. Oftentimes, you only have to verify that 2/3 of the stake weight has signed off. And in practice, this can actually look like, instead of having to verify, 200 signatures, you might only have to verify 20 because like the stake weight is super concentrated in the top like 20 validators. And that's actually true for many Cosmos chains. So in a circuit, one of the flaws is actually you can't do this dynamic logic it's very difficult to do this dynamic logic of like, oh, I only verified the first 20 and then I early exit. Like you can't really do that in a circuit. And so actually for certain computations, I think the lack of dynamic flexibility can actually make it worse than using a VM where you have this like more expressive environment where you can like early exit and like terminate from your computations. And so I think it's really hard to say, even for Tendermint, actually thinking about it more, I am like more on the fence given like some of these like trade-offs. But certainly, yeah, there are applications where if you spent the time and effort, the custom circuit could potentially be like higher performance. But I think that's true of anything, right? Like, for example, there's like, code running in your browser and like, okay, sure, any developer, maybe it could be more optimized or faster or things like that. But the reality is, like, with any engineering task, and if you've ever run a company or if you've ever done any work, you know that there's always way too much work to be done. And you're always trying to figure out, like, okay, where should I allocate my resources? And you're always operating under, like, a fixed resource model. Like, it's not like engineering resources are ever infinite. And there's always really real trade-offs. For example, like, if you have to spend a lot of time coding your ZK circuits, maybe your product is worse because all your best engineers have to like be writing these ZK circuits and not like writing the front end or something like that. So I do think there are perhaps cases where circuits can be better, but then it's kind of this, like, I don't even know if that's like a super interesting question because that's not really a realistic scenario where you would be able to spend all this money.
On the business trade-offs, it doesn't make sense. But I frankly, I was just curious as to how far you may judge on which performance stack could kind of extend it. I kind of want to pass it back to you, Vaughn, Ishri, and kind of ask you how are you, and I'm sure that you have a ton of responses here as well, but how are you thinking about the engineering difference between ZKVMs like succinct and custom circuits, and how are you thinking about making this worth it? Like basically, we just kind of came to, or at least Uma came to the consensus that perhaps there could be applications and use cases that are far better optimized, but it's really just, is it worth it? And so kind of passing to you, like how are you thinking about the developer and engineering lift to make this worth it compared to kind of just using a generalizable solution? And then also kind of feel free to just chime in with your other thoughts on what Uma said.
Vertex Edge is now live on Say Network. Say users can now trade 50 plus spot and perp markets with the unified order book liquidity of Vertex Edge across Arbitrum, Blast, Mantle, and Say. The next 6 weeks, 850,000 Say tokens will be up for grabs as trading rewards every single week, exclusively on Say. Join Vertex on Say Network now on Vertex Edge. That's vertexprotocol.com.
Perfect. My short answer is that it'll make sense. Putting that much effort on engineering can make a difference. Let's take an example. Uber, right? Uber started off in LA in a few cities where they were trying to find product market fit. They were trying to get to market. And all they did in their product was to figure out how to get a person from A to B. They even subsidized heavily. I love the amount of money they would give away just to go from A to B. And look at now. the situation now. The situation now is that they have found the product market fit. They have become so huge that they are operating in various countries, many countries. The number of rides that they have served is phenomenally huge. They have impacted a huge part of the world. And time to market and engineering costs aren't a problem at all. Two examples here. One is that they were using Google Maps initially when they launched their product initially. Now they have their own maps. They build their own maps. It isn't a small engineering feat, but it could impact the entire world. But the amount of the little changes in user experience, of course, it could be little. I instead of waiting for 3 minutes, if instead of waiting for, let's say, let me give these numbers. If instead of waiting for 1 minute, if I'm waiting for 10 seconds, it's a huge improvement for me. And you might argue that, there are multiple other headaches for a company to figure out. All they should care about is to take a person from A to B. But when a company reached at the level that Uber has reached, when they're competing with a company like Lyft and other companies in the rest of the world, these numbers matter. They will put aside money that they have done. They will take the time to build these things like they have done. Similarly, in our space, like we're talking about projects that reach the level of maturity and scale like Uber has reached, the little benefits you get by moving from ZKVMs to custom circuits, the little tiny benefits that you get can impact that level of the world. When bootstrap constraints don't matter, these companies put performance in center stage and take the decisions of choice of their stack where performance matters. This was in response to this question. I have a couple of other responses, but I can wait, or I can go with them.
I guess one thing though is, for example, rollups are probably the biggest category of ZK today. And I think if you talk to any ZK rollup founder, I mean, certainly like we're working with Optimism. They're an extremely large rollup and rollup ecosystem. They do impact the whole world. They have a very global customer base. They have a ton of TVL, like billions of dollars. And even for them, they want to use a ZKVM to prove the Optimism state transition function and maybe one day make Optimism a ZK rollup. For them, having ZK circuits is just not even a consideration. And if you talk to any ZK rollup founder, like, okay, ignore all the Optimisms and the Arbitrums, but you talk to like Scroll or ZK Sync or all these people, or Polygon, even they all agree that ZKVMs are the future of their ZK rollups. And they say, like, yes, a RISC-V like or RISC-V based ZKVM where most of the logic's written in Rust, and then you can have these custom precompiles, and that's something I didn't touch upon. SP1 actually has it's kind of flexible. It has this notion of precompiles where basically you can have custom circuits for specific operations kind of interoperate with the main ZKVM. And so you can kind of get the best of both worlds, because like for very, very computationally intensive things, you can make a custom circuit for it. And we actually do this for hash functions and verifying signatures. That leads to like the order of magnitude speedup we've seen. That ends up being like a very effective trade-off. And so I guess my question is, rollups are the biggest ZK consumers of ZK today. And even all those teams think ZKVMs are the future. So what's kind of the scale of an application that's needed to warrant ZK circuits if the biggest applications of today don't think that ZK circuits are right for them?
Actually, that's a great question. 2 points. One is that Optimism, when it is embracing ZK, think of them as starting on the ZK journey. They're starting on the ZK journey where they're trying to find their place in ZK by rightly adopting ZK through ZKVMs. And I think the future is to tell when the ZK integrated version of Optimism will mature. And the other question you asked is why are these rollups thinking that ZKVMs are the future? I think for rollups, ZKVMs forever will be the future, because on rollups, you have applications. So the ZK rollups themselves aren't applications. They are a platform on which applications are built, right? ZK rollups are giving you the tech to build applications on top of. So the tech they are giving the applications is ZKVM. Please come, adopt ZK, embrace ZK, build on top of us. This is the right gateway. Build your projects, right? They will always have ZKVMs. Imagine an application on top of one of these rollups becoming so big that for them it might make sense, right? For them it might make sense, but the rollup will always continue to offer ZKVMs, because as long as, so here is my core point, right? As long as here is my core point. Here has always been my core point that is for your argument, not against your argument. The for part of my argument is that as long as there are projects that are starting to build, that is how long ZKVMs will be relevant. So ZKVMs will always be relevant. When applications mature within a ZK rollup ecosystem, that is when it might make sense for them to reconsider what is the right application. And a point, so that is my response about how ZK circuits will fare in the ZK rollup ecosystem. And one other point that I wanted to make is about precompiles. Precompiles, like Uma said rightly, are that they are because they are ZK circuits themselves, right? If we are to talk about applications where it might really make sense to think about custom ZK circuits, are places where it's very slightly away from, let's say, a SHA function. Let's say somebody is just proving that I have a preimage to a hash function. At that time, it may not make sense for us to use an entire ZKVM. We can just probably use the precompile that SB1 has within it, that specific custom circuit. Here is another example. If you can, so the entire world is using HTTPS, right? We have very simple math going on in HTTPS. We have some lower value and there is an exponent, and you all the time you're recognized as a person who knows that exponent. And whenever you're building applications that uses that, for example, TLS notary or anything that talks about anything that is bridging the Web 2 to Web 3 parts of the world, there you'll probably have to prove something about what has happened in Web 2. There, computation is very simple, like we were saying, right? There's something in the base, something in the exponent. You're just proving something. You're proving that you know the exponent. There's a very, very simple proof that exists, the Sigma protocol. Just 3 elements, very simple proof. It's one of the first it is one of the first proof systems that there existed. Extremely simple. That is probably all that we need. And there can be many situations like this. I think ZK rollups are good examples where variety of applications come into place, and ZK VMs are the right choice. And maturity can open up space for custom circuits. But there are also applications where custom ZK circuits can readily make sense, can definitely make sense, if not at the very beginning.
Uma, I just want to kind of have you respond there, and then I think probably going to wrap here. Just want to be respectful of your guys' time. Rob, unless you have something else as well.
I mean, maybe I'll just throw in a quick thought, which is that I'm coming to this analogy of the app chain thesis with respect to ZK. And so right now, projects start on general rollups until they graduate, they find product market fit, and then they kind of outgrow their ecosystem and then go build something custom. And it seems like we're always going to have general rollups because projects are always going to be building something new. But then, assumingly projects are able to reach some level of scale, they'll want to internalize their MEV. They're going to want some customizations. And so I just kind of am seeing this this analogy. Feel free to tear it apart as much as you like.
No, I think that's a great analogy. Like, for example, you have all these chains making their own custom modifications to rollup stacks and whatever. But I think actually that kind of even proves my point more, which is when people make new rollups, they're usually taking something like OP stack and modifying a small piece of it. So it might be like, oh, I'm modifying the sequencer to do like, some in protocol MEV recapture. Or okay, let's look at Blast. They took OP stack, they forked it, they made a 1,000-line diff to do this like rebasing yield native asset thing, right? But they didn't go build their own OP stack. Like that would be insane. So I think I actually view ZK really similar, where it's like you take SP1, and then you use SP1, and then you're like, oh, my application's really big. I want to do these like modifications, make it more faster, more performant. Okay, let me add a few pre-compiles. But the core of the logic is still very much the same. And actually, some teams have already done this. So, for example, Lark Labs, they're like a very sophisticated ZK team. They took SP1, they forked it, they added their own pre-compiles for making an Ethereum-like client in SP1. It was really awesome. We merged those back upstream. And now like everyone else benefits in the ecosystem. So I think like I'm very supportive of that kind of stuff. And I think that makes a lot of sense, where it's like you take SP1 and maybe there's like some new encryption algorithm that pops up or some new hash function that gets popular. Okay, SP1's fully open source. You can customize it as you want. And then one day maybe we'll merge it back upstream and, then everyone can benefit or maybe not. And maybe other people can just like take your fork and go from there. That's kind of how I see the future. I think in a similar way to how people do not try to build another OP stack from scratch, because that's just, if you look at the OP repo, it's like 20,000 commits. The code base is really huge. Like that's just not going to be a fun time. And you're honestly probably not going to build something better because they've like thought about it a lot and iterated a lot to get to that point. I think in a very similar way, like SP1 is extremely complex to build. It's really, really hard to build. Like we have spreadsheets and spreadsheets of data on like, oh, what are like the different bottlenecks? Let's optimize it. And we've run a lot of different workloads and a lot of different use cases to really like achieve all the things we've been able to. And so I think it's just really going to be really, really difficult to build something from scratch that's like better or like even more competitive, even for your particular use case. Because like there's just a lot of iteration that needs to happen. But I think customizing like a core base makes a lot of sense. And like I view OP stack, app rollups on top of OP stack, or even like Cosmos SDK app chains. Like you're not building a new Cosmos SDK. You're using the Cosmos SDK framework and then customizing it where you need to build your chain. And that also makes a ton of sense. But yeah, building something from scratch, I think is just going to be like very, very difficult. And so, yeah, I think actually, Robbie, your point around the op-chain thesis, I think I'm actually very much in agreement with it, and I think it like kind of supports my point. And that's how I see like the future of customized ZK playing out.
Cool. Makes a ton of sense. Well, guys, I think this is a good place to wrap. This has been a really fun, and I'm glad that we were able to talk about ZK with two people that are very well versed in the subject. So thank you so much for coming on and sharing your thoughts.
This was
Yeah,
fun.
and I just want to add, I hope that once Von Rishi comes out of stealth with what she's been building, that you guys can collaborate as well. I think there's going to be a ton of cool ideas that can come from this. And it was a pleasure to have you guys on.
Cool. Yeah, thanks for having us.
Yeah, this was fun. Thank you guys for having us.